All right, lesson 7.5, video 2. Got 3 slides. That's all. All right, and then we'll be done. Okay, so example 4. It says in triangle KLM, that's the big triangle, segment NL bisects angle KLM, and we're showing that by these congruent markings right here. Right, if angle bisector. Compare the ratios of Kn over Mn and KL over ML. So let's do that first. So what is Kn over Mn? So Kn is 10.5 over Mn, which is 7.5. And I would just use my calculator to divide them, and I got 1.4. Okay, I think that's nice and even, I think. 10.5 divided by 7.5. Yeah, 1.4. And now I'll do the other ratio they want to compare, which is KL over ML. So KL is 14 over 10. And again, I know that in my head, just move the decimal place 1 to the left when you divide it by 10. That is also 1.4. So because of this, they are proportional. Kn over Mn, the two parts of this segment, are proportional to KL over ML, these two sides of the big triangle. Okay. But now the question is triangle LKN similar to triangle LMN? Well, these would be two pairs of sides, right? So notice where KN and MN are, they're here, and then KL and ML are here. So to use side angle side, we'd have to know that angle K is congruent to angle M. We don't know. So is angle K congruent to angle M? I don't know. The other thing to do is you could compare the third side. Well, the third side of both triangles would be NL. Well, if you compare NL to NL, that's going to give you a ratio of 1, which is not equal to 1.4. So then we could not use side similarity. So because of this, I don't think the triangles are similar. I think triangle LKN is not similar to triangle LMN. Okay. So these segments are proportional, but those two triangles are not similar. Okay. So the idea behind that was to explain, right, that they're not similar. So we do have this theorem. It's called the triangle angle bisector theorem, right? It does say if a ray or segment or line bisects an angle of a triangle, which it does here, then it divides the opposite side. So the opposite side of the angle is UW into two segments. So UW is UX and WX, these two, that are then proportional, or the same ratio as the segments, the ratio between the sides adjacent to each segment. So these two sides here, right? So it's, UX and UV are on top. And then you have XW and WV are on bottom, right? So that kind of look, right? That's your proportion, right? Now, lucky for you, you're going to prove that in exercise 16. This is not an easy proof. So I'm excited for you to do that. I think I did it for my first time when I started teaching honors geometry. It's really fun. It's a good proof, right? But it involves like extending sides. So you create some similar triangles, and then that's how you get these ratios. Okay, but again, these two triangles here and here are not similar. So keep that in mind. Okay, cool. All right, so let's see if we can apply this rule. So what are the values of AD and DC? So here is that angle bisector. So the side that is opposite is AC. So we're going to break AC into two parts. Let's call it AD and DC, right? And then on top is going to be the side adjacent to AD, which would be AB. And then on bottom is the side adjacent to DC, which would be BC. Now, the issue of this is that 13 is the length of AC, right? We know what AD is. AD is X. We don't have an expression for DC, but we can create one by taking the entire length 13 and subtracting the smaller length X. This is going to be your length of DC, 13 minus X. It is a binomial, so I'll put it in parentheses. And then we know that AB is 10 and BC is 16. We're going to cross multiply. Again, if you want to distribute, you can. I'm going to just write it 10 times 13 minus x equals 16x. I'm going to distribute. So 10 times 13 is 130. 10 times negative x is negative 10x. That equals 16x. We're going to add 10x to both sides. So we get 130 equals 26x. And we're going to divide by 26. And we get an x value of 5. And they want to know what AD and DC are. So we know that AD is exactly x. So AD is just 5. And then to find DC, we're going to take 13 minus 5, which is 8. And there you go. So that's applying the triangle angle bisector theorem. All right, great work. Thanks for watching. Good luck. We'll see you in class.